Hello everyone. Welcome to the solution of LeetCode problem 450 named delete node in a binary search tree. In this problem, we are given the root reference of a binary search tree and the key. Now we have to delete the node with the given key in this binary search tree. And we have to return the root node reference of the binary search tree after the upgradation. And basically, the deletion can be divided into two stages. Search for a node to remove, and if the node is found, delete the node. So here in the first example, the root is 5, which has two children, 3 and 6. 3 has two children, 2, 4, and 6 has one children, which is 7. So here the key is 3. So if we delete this node 3, this node 4 will take the place of 3. So 4 is taking the place of 3 here. So this is the resultant binary search tree, so we have to return it. I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, to understand the algorithm, we have taken this example. The root is 15, which has two children, 10 and 20. 10 has two children, 8 and 12. 8 has one children, 6. 12 has one children, 11. 20 has two children, 17 and 25. And 27 has one children, which is 16. 25 has one children, which is 27. And this given tree is the binary search tree because for any of the root, all of the value in the left part is less than the root, and all of the value in the right part will be greater than the root. And this is true for each of the node. Now we have to remove the node 15. So if we remove the node 15, this node 16 will take the place of this node and the tree will become something like this. So here this tree is also a binary search tree because all of the left part value is less than 16 and all of the right part value is greater than 16. So the question is, how can we basically solve this problem? We can solve this problem by using the in-order successor technique. So what is the in-order successor? In-order successor is, suppose for this node 15, the in-order successor is 16 because we have to find the minimum value which is greater than the node in the binary search tree. So here the value 16 is the minimum value which is greater than the node 15. So we can say that node 16 is the in-order successor of the node 15. So here, suppose we have to remove the node 15 here. So there can be two conditions. Either we have the right subtree or either we don't have the right subtree. Why we take consideration only the right subtree in the solution? Because the in-order successor will be always found in the right subtree's left part. This is the right subtree and the successor can be found in the left part. So we will take consideration the right subtree always. So here if suppose let's say this portion is not presented here. Suppose we have to delete the node 15. So here we have no right subtree. So we can simply return the left tree part which is into this portion. This is the one case. That means here we can simply return the root of left and delete the root. This is one condition. Otherwise, if we have the right subtree, suppose for this binary search tree, we have the right subtree, and here we have to find the in-order successor. Suppose here the in-order successor of 15 will be we have to get to the right children. Yes, we have right children. After that, we have to get to the as minimum left as possible. And finally, we will get the in-order successor. So here the in-order successor is 16. So we will swap the value between 15 and 16. So 15 will become 16. After that, and 16 will become 15. And we will remove the value 15 here. Now, this tree is becoming, the root is 16, which has two children, 10 and 20, and so on. So here we can see that this portion of the tree, or this portion of the modified tree, is the modified binary search tree after deletion of the node equal to 15. And basically this is how we're gonna solve this problem by using the in-order successor technique. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named delete node, which is a root and a key as a parameter. And if root is null, we have to return the null pointer. Otherwise, if root value is equal to key, and here two condition, if the root does not have any of the right children, we have to store the root of left value to a left variable and delete the root and return the left variable. Otherwise, if the root has the right children, that means we have to find the in-order successor of the given root. And here we have to store the right subtree reference into a variable right. And while we have to go as deep as possible left and assign the variable, or assign the left node to the variable right. And finally, after completing this while loop, we have found the in-order successor, which is stored in the right, and we will swap the root value and the right value. After that, we have to recursively call the DFS function into the left and the right subtree with the given key and assign them to the root of left and root of right children. Finally, we have to return the root. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.